Hello everyone. This is the heart disease analysis dashboard that me and my teammate developed using D3JS. The purpose of this dashboard is to transform complex heart disease data into a clear, dynamic, and interactive visuals that can assist various users in understanding the factors by contributing to heart disease. The heart disease remains a leading cause of death globally, and analyzing related data can uncover patterns that improves diagnosis, treatment strategies, and patient outcomes. So this project leverages D3JS to create a suite of visualizations that not only display data but also allow users to explore it actively, making it a valuable tool for both analysis and education. So coming to the dataset, this dashboard is built on a dataset containing patient records with several clinically significant variables. Here's a detailed look at each. The first variable is age of the patients, and the second variable is the chest pain type. It is categorized into four values. The third is the cholesterol level. Fourth one is the maximum heart rate achieved by a patient. Fifth is the presence of the disease, and then the resting blood pressure, and then the ECG values, and there are some other variables. This data set is derived from a clinical study. We obtained this data set from Kaggle. It provides a robust mix of numerical and categorical data. It's been pre-processed to focus on these variables because they are widely recognized by cardiologists as key indicators of heart disease risk. This dashboard uses this data to highlight trends, correlations, and patient subgroups, making it easier to spot actionable insights. So coming to the visualizations, this dashboard features 6 distinct visualizations, each designed to reveal different aspects of the data. Here's a deeper dive into each of the visualizations. So the first one is the animated line chart. This chart plots maximum heart rate on the y-axis against the age on x-axis for all patients, with an animation that draws the line progressively from younger to older ages. You can view the animation when this is started. This is the animation we have added, and this animation not only makes the visualization engaging but also emphasizes how maximum heart rate trends downward with age, while highlighting outliers where this trend breaks, potentially indicating disease. So for interactivity, we added a hover function where you can see the age and the heart rate of that particular point by hovering over it, like this. And you can also click on a specific point that filters the entire dashboard to that patient's data, syncing all other visuals like this. So this shows that this patient has no disease and he's in the first value of the chest pain type, which is asymptomatic. And you can also see the sunburst graph aligning towards it. And we can use this reset filter button to get the dashboard back to the main visualization. So this line chart is ideal for spotting age related heart rate anomalies, which could prompt further medical investigation. And the second visualization in our dashboard is the stacked bar chart. This chart breaks down 4 of the chest pain types into bars. Each bar are stacked to show the proportion of patients with disease and no disease. So for example, the non-anginal bar shows the highest proportion of disease positive patients, underscoring the danger of silent heart conditions. Interactivity, it also has the hover function where you can see the chest pain type and also the number of people with the disease and without the disease. So here there are 375 people with no disease and there are 122 people with disease in chest pain type 0. This is for chest pain type 1, chest pain type 2 and chest pain type 3. And you can click on a particular bar and it filters the dashboard to that specific set of patients. So for example, I'm clicking on chest pain type 0 and the no disease function. So it shows the people with no disease in the asymptomatic part of asymptomatic chest pain type region. So it filters like that, and you can also select disease. So for example, I'm selecting the disease category in chest pain type 2. So this filters the data according to that, and then I can use the reset filter function to get back to the main visualization. And the third one is the sunburst chart. This is a hierarchical visualization where the inner ring represents the chest pain types and the outer ring shows disease presence within each type. The radial layouts uses segment size to reflect patient counts, making it visually intuitive to compare disease prevalence across symptoms. This also shows the number of patients across that segment while hovering, and you can also click on it. So for example, first I'll click on CP1. It shows people with disease and no disease in the CP1. It shows the entire set of patients in CP1. The entire dashboard filters out to that, and now I can also select the people with disease or no disease. For example, I'll select the people with disease, so it filters out like that. And again, I can click on CP1 to get back to normal, and then select people with no disease. So these are the interactions for the sunburst chart. And now coming to the next visualizations, my teammate will be explaining about these visualizations.
And coming to the next visualization, it is a cluster scatter plot. This plot highlights the patients by the age, and on the x-axis we have the age of the patients, and the y-axis we have the cholesterol. We took K-means clustering. We have 3 clusters optimal, and the cluster reveals natural grouping like older patients with a higher cholesterol indicating shared risk profiles. Like here, we click on this, you can see that the patient has a chest type 2 and has suffering from the heart disease, and he is around 66 years, and heart rate is around 177. We can explore all the graphs, and after that we can see from here that if the age increases, the cholesterol is also increasing, and the risk of the heart is also increasing. And after that, when we go to PCP plot, you can see that from age to trust BPS there is a negative correlation, and from trust BPS to cholesterol it shows a curve like feature, and from cholesterol to TAL CH it shows an upward trend, and after that from TAL CH to old peak it shows a downward trend. And if we can just, we want to find the distribution of age and cholesterol, we can drag like this, and we can show that there is a correlation between the age and the TAL. Like if we click on the one patient, he has age 70, but he has cholesterol less compared to others, and the test BPS is also very low, indicating that he does not have any blood pressure. And after that, TAL CH is for is around 150, and the old peak is nearly close zero. This indicates that patient is not suffering from heart disease. We can get the details of each patient like this. And if you go to the scatter plot, here we can see the scatter plot between the age and the scatter plot matrix, and we can see that the correlation between the age and the TAL CH, and age and the cholesterol, and age and the test PPS, and we can see from that age and the cholesterol is showing a slightly upward trend, and the age and the TAL CH showing a scattered plot. And we can explore the each scatter plot of the variables here. And if we go to the features, like we explored the future as many people in the around US, 2% of the people is suffering from color blind, and we want to show the colors accurately for them. So we have implemented this feature, and if we click on this, you can see the color changes according to the color blind. Intensity changes, and it is easily seen by the color blind as the intensity changes. uh, and if we and we also implemented different themes like ocean view, like all the graphs turned into ocean color. And we have sunset color, which the the graphs highlight the red sunset color, and the forest color highlights the green color. This is the overview of our project. We can just hover over the project. We can see the values, and if we click on the any one, it will show the values of that variable. And here is our project for a heart disease analysis. From this we can find the conclusion of the graphs.
In summary, this heart disease analysis dashboard offers 6 interactive visualizations to explore heart disease data by linking it through clicking with user controls for themes and accessibility. It is also a valuable tool for medical insights with great potential to expand, perhaps even by adding some more variables for predictive analysis. Uh, Thank you so much for listening to our demo of the heart disease analysis dashboard. Thank you.